Now the equation, you know, VGS equals to minus ID into RS. I am using this equation. VGS is minus ID into RS, which you have already derived. What you can see from this equation, it defines a straight line. This equation is again of a straight line with a slope. On the output characteristics, you have VGS versus ID. So VGS on x-axis, ID on y-axis, and negative RS is the slope. So negative slope, it is similar to the DC load line what we have done. Now what we can do, we can identify 2 points on this graph. Why? On this side you have the transfer characteristics, as you know, IDSS and VP. How to draw the transfer characteristics, that point has been cleared. Now these 2 points, and when you draw a straight line, and what you get, that will be your Q point, right? So that will go stepwise. So what we are doing, we are drawing a line with 2 points, say 1 point here, 1 point here. We need to identify these 2 points. Now one condition is, if ID is 0, that is on the x-axis. So in this equation, if I put ID to be 0, what will be my VGS? VGS is minus ID into RS. Since ID is 0, my VGS will be 0. So which is that point? This is the point when your VGS is 0 and ID is 0. So we got 1 point on the graph where you have VGS on x-axis and ID on y-axis. Now for second point, we need to choose the value of either ID or VGS and find the other value. Using which equation? We can use this equation to find the other point. Now the resulting level of ID and VGS will define the another point on the straight line. For example, if we take ID equals to IDSS by 2. IDSS will be given in the question. So IDSS by 2 if I am taking, then what will be the value of VGS for this? I will have VGS as minus ID into RS. So it will be minus IDSS RS upon 2. So this is 1 point. So what value of ID I am taking? Suppose say this is your IDSS. Here is your IDSS. Half of that will come here. So IDSS by 2. For IDSS by 2, I will get some value of VGS. So when you put that value, you will get some point. Suppose say this is the point. And what I will do, this was the first point which I got after substituting ID is equal to 0. What I will do, I will just join these 2 points. I will get a straight line that is satisfying this equation, right? Now you know to draw the transfer characteristics. As I have told you, you have VP, that is x-axis, you have VGS. The point where we stop is VP. So you know how to draw by taking 2 points. One coordinate is ID is equal to IDSS by 2. For this you will get VGS is 0.3 of VP, and for VGS is VP by 2, you will get ID is equal to IDSS by 4. These are the 2 points. So for this condition, you can find 1 point, say VP by 2 and IDSS by. So wherever this line intersects the transfer characteristics, this point is your IDQ and this point is your VGSQ. This is how you can find the Q point graphically. So what you will get? You will get 2 points, IDQ and VGSQ from the graph. Once you know IDQ and VGSQ, you can apply KVL in this loop. So what will be the KVL? VDD minus IDRD minus VDS minus IS into RS equals to 0. So I can find VDS as VDD minus ID into RD minus ID into RS, because IS and ID are same. So I can substitute this. So I can find VDS as VDD minus ID, if I am taking common, RD plus RS. So I have got VDS. Once I know VDS, I can find VDS is nothing but VD minus VS. We know VS is ID into RS. So once you know ID, you can find VS, and once you know VS, you know VDS, you can find VD. Then since VG is 0, you know VGS is VG minus VS. Since VG is 0, VGS and VS are same. There is one more method to find VD. You can find VD as VDS plus VS, the same thing rearranged, and which is nothing but VDD minus voltage drop across RD. So VDD minus VRD is again the same thing. How you got this is from this equation. VDS is VDD minus IDRD minus ID into RS. So voltage across ID into RD is VRD. This is how we can solve the problem.